All right, boys and girls, welcome back to the drive-thru. Hope everyone had a great day. As always, the drive-thru sponsored by the deli. Hungry? Stop by the deli. Get yourself a sandwich. All right, so these are the notes for 9.2 and 9.3, and it's the introduction to section 9.3 homework. We don't have an assignment for 9.2. It's kind of review, and we'll have an entire chapter on circles coming up next in chapter 10. So I want to teach you what you need to learn without giving you a required assignment. So hopefully you all know that the area of a circle is equal to pi r squared, and that the circumference of a circle is equal to 2 pi r, or pi d, because two r is equal to d. Okay? You should all have already understood that. So this is, I guess, new. It shouldn't be, I don't think I should have to teach you guys this, but I gladly will. Okay? The arc length inside of a circle. Well, in order to know the arc length, you need to know the arc measure. And that may seem redundant, but we are going to say that an arc measure is in degrees. So let's say that here we have an 80-degree arc, okay? And that the radius of this circle is equal to 10 units. Let's say 10 centimeters. Okay, well, every 80-degree arc is not the same length. Think about it. An 80-degree arc on the Earth is humongous, okay? An 80-degree arc on a basketball isn't that big. It's measured in inches. So, in order to figure out the length of an arc, you just take what portion of the circle that it represents. So, that arc is 80/360ths of the entire circle. And then you just multiply times the circumference. Okay? So, I don't know, let's just do some well, screw it. 80 times 20 is 1600 pi over 360. So that's 160 pi over 36. Oh, geez. 80 pi over, well, here, let's get to this first. 80 pi over 18. Divide each by 9, and you get that is, well, it's not divisible by 9. Divide each one by 2. 40 pi over 9. That is now in a length, okay? I think that's right. So, the arc length of a circle, arc length, is equal to degree, the degrees of the arc, over 360 times the circumference. Okay? So the area of a slice of a circle, if very similarly, if we wanted to find the area of this here is the center, and let's say this is, again, 80 degrees. Well, this is 80 over 360, let's say our radius is still 10, times pi r squared, times 100 pi. Okay, and that would also simplify, and I'm not going to waste your time to do that, because I don't have a calculator and I don't feel like it. So, what's the area of a slice of a circle? So this was arc length. This is now sector area. A sector is the official name for a piece of pie. And that is the degree measure of the sector over 360 times pi r squared. So that's all of 9.2, okay? Now, this stuff is kind of brand new. Not brand new because you proved this on your test that I just gave back. So let me set up this problem for you. Here's what we have going on. We have a right triangle, and then we have Oh, that wasn't very good. An altitude drawn from the right angle, or an altitude drawn to the hypotenuse. Okay, so keep in mind, this is a leg, this is a leg, and this whole thing is the hypotenuse. Now let's give this figure some letters. Well, what you should see here is we have three right triangles. We have a small triangle, we have a medium triangle, and we have a right triangle. Oh, sorry, a large triangle. And all of these are right triangles. Okay? In the small triangle, C is the right angle, and it looks like we could call this B, and then this would be our angle A. Let's dot this here so we can keep our triangles straight. Okay? All right, well, now let's go over to the big triangle. In the big triangle, A is our right angle. B is over here, our dotted angle. And then that makes this D up here. Okay, so now we've got to figure out in our medium triangle, well, in our medium triangle, C is our right angle, and angle D has to be angle D still. There's only one angle D, which means that it must be up here. So in this case, this part of angle A, angle CAD, is our dotted angle. So now we have successfully rewritten these triangle 1, triangle 2, and the entire triangle so that they're all facing the same direction. So now we can see that AC is to CB like CD is to CA like AD is to AB. But you could also say that AC is to AB like DC is to DA, like DA is to DB. And if you remember from the test, here you could get DA squared is DC times dB, and that was kind of like what we wanted to prove on the test. Okay? So, if you understand that there are three right triangles created, then I can give you the shortcuts, the theorems. So again, I'm going to rewrite this right triangle with an altitude drawn to the hypotenuse. But now we're going to retitle things for the sake of these theorems. Okay? So this we're going to call leg 1. This we're going to call A for altitude. This we're going to call leg 2. This whole thing we're going to call the hypotenuse. This we're going to call P1 for part 1, and this is P2 for part 2. Okay? So, there's the first theorem. altitude squared is part 1 times part 2. You might be asking yourself, where did that theorem come from? Well, just uncross multiply it. If it's altitude squared, then it had to start like this. So this could be P1 down here and P2. Well, let's look at it. A is the P1. So that's the long leg from triangle 1 is to the short leg from triangle 1. Like the long leg from triangle 2 is to the short leg from triangle 2. That's where that came from. Okay? So this is one of the theorems. The other two theorems would be this. L1 squared is equal to P1 times H. Okay? If you're wondering where that came from, L1 here, L1 here, P1 there, and H here. Let's see if we can find that. L1 is to P1. Hypotenuse from the small triangle is to the short leg of the triangle, like the hypotenuse of the big triangle is to the short leg of the triangle. That's where that came from. Okay, and then finally, L2 squared is going to be P2 times H. Okay, so here is a summary of the theorems. Altitude squared is part times part. Okay, and hypotenuse squared, leg squared is part times whole. Okay, that will get us through the start of this, and then stay tuned to some more questions as I go over the examples. You can see the Blackboard site for some examples of this in motion. But in general, these are the key critical theorems from today's section. Boom!